Look at this iconic photograph from the Apollo era. For 50 years, the strategy for the moon was limited to brief, temporary visits. In late 2025, NASA made a sudden strategic pivot. The agency halted development on the Lunar Gateway, a planned orbiting space station, and redirected all funding and engineering talent directly to the lunar surface. That decision came with a $20 billion mandate to build a permanent human outpost. The target is the Shackleton Connecting Ridge at the Moon's south pole, with a fully operational base slated for 2036. NASA Administrator Jared Isaacman is accelerating this timeline, with international competitors targeting their very own lunar landings by 2030. The agency is moving aggressively to secure the region. The first physical hardware for this architecture drops onto the lunar surface later this year. This timeline transitions NASA away from short-duration scientific expeditions and toward the large-scale construction of permanent off-world infrastructure. Astronauts won't be building this initial outpost. Instead, NASA is deploying a fleet of commercial robotic proxies to handle the hazardous site preparation. To illustrate Phase 1 operations running through 2029, the plan calls for 25 rocket launches and 21 landings, delivering 4 metric tons of cargo. Early deliveries include Moonbase 1, 2, and 3, dropping payloads onto 3 specific zones. By 2028, the agency will deploy 4 propulsive drones under the Moonfall mission. These quadcopters will hop into the absolute darkness of permanently shadowed craters to map the steep terrain and hunt for water ice. Following the drones, autonomous ground rovers will arrive to physically compact the lunar regolith, the abrasive, microscopic dust that coats the surface. Achieving pinpoint autonomous site preparation is required to mitigate environmental hazards before risking human astronauts on the ground. Once the site is prepped, Phase 2 begins in 2029, and it faces a severe bottleneck, surviving the 14-day lunar night. When the sun sets at the South Pole, temperatures plummet to -400 degrees Fahrenheit. In that freezing environment, traditional solar panels are useless for 2 straight weeks. To solve that power deficit, the Earth-to-Moon cargo pipeline scales from 4 metric tons to 60 metric tons in Phase 2. That extra capacity will carry fission surface power, early nuclear reactors deployed to provide a continuous energy grid. Mastering this localized nuclear grid is a requirement for human expansion. Without reliable thermal control to survive the darkness, permanent habitation is physically impossible. By 2032, Phase 3 marks the official transition to a sustained colony, with routine astronaut rotations. To keep those crews alive, NASA plans to establish a delivery network, pushing 150 metric tons of cargo to the surface annually. The physical footprint of the base will expand, as temporary commercial landers are replaced by semi-permanent, pressurized habitation modules. To support this expansion, the base will rely on in-situ resource utilization, or ISRU. This involves mechanical systems continuously excavating the gray lunar soil to extract life-saving oxygen, water, and building materials. Manufacturing these survival commodities out of the regolith allows the base to operate without relying on constant resupply shipments from Earth. A self-sustaining industrial loop allows the outpost to transition from a construction site to a functioning independent settlement. So why is the federal government investing $20 billion over the next decade to accelerate this specific lunar roadmap? The moon base forces the commercial space industry to solve the brutal logistics of off-world construction right in Earth's backyard. Every phase of the Shackleton architecture serves as a scaled blueprint for the eventual human colonization of Mars. Testing experimental nuclear reactors and habitats is significantly safer on a 3-day trip to the moon rather than during a 9-month point-of-no-return journey to the Red Planet. After decades of short exploratory flights, the 2036 blueprint establishes the moon as a permanent human residence.